So in today's class, let's see how this a binary tree, what we've seen in the previous session, is going to be represented in computer's memory. So if you just look into the structure of the tree, it is hierarchical and it is not linear. If it is linear, it is easy for us to represent in computer's memory, because memory is also a linear structure, right? I hope you all remember how the memory, physical memory, will look like. We'll have one moment, my tablet stopped working. Okay. So memory, in the very first class when I started with arrays, I helped you understand how the memory will look like. Memory is a linear structure. So if the data structure what we are working with is also linear, then mapping the structure into the computer's memory is easy and direct. But here, the structure what we are now trying to work with is hierarchical structure, and which is not linear and so not easy to map it to the physical memory what we have, which has got a linear structure. So what we are going to do is we are going to find out some of the other way to map the data that is represented using this hierarchical structure to a linear form. So how we go about doing this in binary tree is, so we try to identify the relationship between the values or nodes that are there in the tree. So if you just look into this tree, so here if the parent is at some position, then the children are at position that is related to the position, parent's position. Say for example, say I number the nodes like this, right? I'll go level by level and number all the nodes. So here 6 is missing, and so I hope I taught you what full binary tree and complete binary tree are. Did I? Have we seen full binary tree and complete binary trees?
Yes, ma'am, yes.
Okay, so you know that the binary tree is going to be called as a complete binary tree when the elements or the nodes are in sequence, when the numbering starts from the root position, right? So we use the same numbering technique and try to identify the relation between the parent and the child. So here at this point, root is at position 1 and its children are at position 2 and 3. And similarly, you just look at this part of the tree, which is the subtree of this left subtree of A. Here, B is at position 2, whereas D and E are at position 4 and 5. And coming to the subtree with C as the root. So if you're going to have some node here, then it is going to be there in position 6, and the left child will always fall in the position 7 if the root is at 3. Right? So here the relation between these numbers, if you just look, if you just make it general, when the parent is at position I, then in nodes the left and right child are going to be there in 2i and 2i plus 1. I hope you follow me. So here the root node is at position 1 and its children left and right child are at position 2 and 3. So multiply this 1 with 2. So that is the position of the left child. Multiply this 1 with 2 and add 1 to it. That will give you the position of the left child of that node. Right? So 2 into 1, 2 plus 1, it is 3. So here, what will be the value here of this root? You take that as I. Then the children of it, the left and right child of that particular node is going to be at position 2i and 2i plus 1. So here if you just look at this B, B's position is 2 and 2i is nothing but 2 into 2, which is 4, where I could find the left child of this element at position 2. I hope I am clear and you are able to follow me.
Yes, ma'am.
Okay. Then the right child, you could see it is 2 into 2 plus 1. So the position here is taken as I. Multiply it with 2, you get the left child of the node that is in position I. Multiply it with 2 and add 1 to it, you are going to get the right child of the node at position I. Right? So considering this, I can convert this hierarchical structure into a linear structure which could fit into the physical memory. Right? So here, what I do is, say, I just take the root node at position 1 or at index 1 in the array. Right? So here, if the root node is available at position 1, then its left and right child should obviously be at position 2 into 1 and 2 into 1 plus 1. 2i and 2i plus 1. So here it is 2 and 3. So 2 and 3 are the positions which are going to be occupied by left and right child of A. Now, where do you put the left and right child of B? That depends on the index where this B is getting into. So B gets into position 2. Then you have to store this D and E, which are left and right child of B respectively here. You take to position 4 and 5. So here 2 into 2 is 4. So you could see that left child of B has gone into position 4 and right child of B has gone into position 5. Right? Similarly, taking the next element, that is C, which is at location 3. So here the child or children of the C should get into 6 and 7. 3 into 2 and 3 into 2 plus 1. So I just go to position 6 and 7 and fill the values. But here C do not have its left child but have its right child. So I just take only the right child and fill it in position 7. This position should not be changed. If you are going to change the position of these values, then the children will get changed. It will get mixed up. That should never be done. So if a particular node has got no child in left or right, then you just leave, you have to leave that particular position blank or empty. Clear? So here the idea is very simple. Root is always going to be at position 1. Then the children of root will be at position 2 and 3. So if this root do not have this C, right, assuming that there is no right subtree of A, then this position 3 will be left blank, right, because it is null, indicating that this A do not have a right child. I hope you follow me.
Yes, ma'am.
Yes. Any clarifications in this? தமிழ்ல சொல்லணுமா? யாருக்காவது தமிழ்ல இதை டீச் பண்ணணுமா?
No, ma'am.
Okay. Then let's move on to the next one. So this is how the tree could be represented using arrays. So this is array representation of binary trees. Okay. So this is applicable only for binary trees. That is most important. So representing binary trees is going to be simple when it is represented using arrays, right? But representing general tree is not possible at all, because here you do have a constraint that every node is going to have maximum of 2 children, not more than that. But that is not the constraint over general tree. So it is rather difficult for us to determine how many positions we need to leave blank or how many positions we have to assign to a particular node to store its children. So that is going to be difficult. So we will never use general trees in computing systems. We only use binary. If at all we need to use general trees, then we will just apply the method to convert the general tree into binary tree and then use it. Okay. So I hope this is clear. Now let's see the linked representation of binary trees. Just a moment. I'll have a cup of water and come. So here the next way we can represent the binary tree is using linked list or linked representation of binary trees. Okay, so here this is going to be represented directly with the help of a linked list node. So here we know that every node is going to have 2 children maximum. So we're going to declare 2 link fields, one named as right link and the other one named as left link. And in between we're going to have a data field. So here in the data field you're going to have the data stored, and the left link field is going to point to the left child. Okay, so here B and the right child. Again, every element here will be stored in the form of a node having a data field and 2 link fields, right? We will have a similar structure throughout, and this is possible only because of the constraint that every binary tree can have maximum of 2 children, right? So you need not declare any extra number of link fields, because for sure we are going to work only with 2 children, left and right. So here you have left link and right link attached with every node. So if B has got a left child, then you have to again create a new node and store the data value of it, and B has got here a right child also. So I am just drawing this tree using this example, right? So we have E here, so we create a node for E and make this right link of B point to E. And similarly here C has got no left child, so the left link field of C will be null. So see here, one thing I wanted to tell you. So if C has got only one child and if the direction is not given, then you have to take that to be a left child, right? So here there is direction is not mentioned, it is given directly here in between. So we are going to consider that as left child. Normally that should be the procedure, because in that case the tree will become a complete tree, right? So if it has been given like the one which we have seen in the previous example, there F was given the right side of C, so we have to take as right child of C. So that is what we did, but here in this diagram it is given directly, in which case you have to choose that to be the left child. But here I think this is typo, it should they have taken the same diagram what has been taken in the previous slide, so let us assume that this is left child, so sorry, right child, and we'll have this left link to be empty, and here we'll have F, and all the leaf nodes will have their link field as null. Okay, clear? So this is how it is going to look like, and this diagram shows how the links has to be followed, and this again uses an array to explain you how these links are being followed from the root. See here we have the 5th location is assigned to A, right? So we have the information field which I call as data, and this is left link field and this is right link field, which are going to have addresses. The 0, 0, 7, 2 are all addresses, right? 0 means null, so it is not a valid address here, right? So valid addresses are here from 1 to 10. 0 is not valid, which means that 0 is null. Hope you follow me, right? So now start from the root. So here root's left child is at position 7. So at position 7, go to 7. So what do I find there? It is B. So left child of a root node is B, right? And what is the right child of root node A? It is at 1. So here just a second. So here the right child of A is at position 1. So we go to the address 1 where I can find the right child of A. So right child of A is C. You could see in this address 1 C is stored. Right? Now If you want to just check the left and right child of B, go to B. B is at 7, right? So you need to traverse from the root again. So because as in the case of linked list, here in the case of trees, you're going to know only the address of the root node. So start from root. So root's left child is B. So you go to B, and if you want to get the left child of B, then take the left field. So where you have value 2 stored. So go to location 2. Going to location 2 to get the left child of B. So at location 2 you can find the left child of B. Right? So instead of just showing you the diagrammatic representation, they have given like this. Right? So meaning that this left link has got 7, and this is the address of this node B, and right link has got 1. Shall I redraw this, or are you able to follow this? So I have shown the links directly. Instead they have given the address values of these nodes. So address of root is 5, and address of this B is 7, which in turn should go into left link of B, because you should have a link from left link field of A to B. That is why you have 7. I hope you follow me. Do you want me to redraw and show?
No.
Okay. So here in the left link of B, what are you going to have then? It should be 2. And right link of B should be what? 4. So 4 is nothing but address of E, and this 2 is nothing but address of D. Hope this is clear. So this is how a tree will be represented as a linked structure, or linked list. Representation of tree is this, wherein the node has to be created with a defined structure of having one data field and 2 link fields, one for left link and another for right link. And the left link field is going to have the address of the left child, and right link field will always have the address of the right child. I hope this is clear. Shall we move on to the next?
Yes, ma'am.
Okay. Right. So next is about traversal. So as we've seen in the previous sessions, every data structure that we define and declare, we need to know how to move about in the structure. So we have to just visit all the data, so that it will be possible for us to explore the structure and also do some processing on the data that is stored in the structure. So that exploration or visiting all the data that is stored in the structure is called as traversal. So this is the primitive function that any data structure should be defined with. So here again in tree we are going to have traversal. So here basically we have 3 different standard traversal technique. One is in order, and the other one is pre-order, and the third one is post order. And also we have one more type of traversal, what is called as level order. And you can have many different ways in which you can move around, but these 3 or 4 are the standard traversal techniques. So in order, what we actually do is, you have to keenly note this is very important. So in order, what we do is, we always try to move left, then visit node, and then move towards right. Okay, and in pre-order I explain this again with in detail with an example. Okay, don't worry. And pre-order, we just first visit the node where we are. Visiting means just go explore it. Okay, so explore the data in that particular node, and then move towards left and then to right. Okay, and in post order, first visit left child, then go towards right, and then explore the node. Okay, so in level order, you go level by level. Explore all the nodes at level 1, then explore all the nodes at level 2, and it goes on till you reach the last level of the tree. Okay, so we are not going to have a look into this level order. This is not of our concern. We need to just look into these 3 standard traversal techniques in trees. Okay, I'll just take an example and explain. and then explain you the algorithm. Let me take a simplest example and show you how these three traversal techniques work. Okay. So what we do actually in pre-order is, let us go in order. So in pre-order, you print actually the data when you reach the node for the first time. So always we know that the traversal should start only from root, because we know only the root's address. Okay, so start the traversal from root. So whenever you reach a particular node, immediately for the first time, immediately you print the node. Printing is the processing what I'm going to do. So you can do whatever processing you want to do, right? But here we are trying to print. Let's assume. I hope you follow me. Purina?
Yes, ma'am.
Okay. So now we start the traversal from the root node. So here we visit the root node for the first time. So we're going to print it. Okay. And now after traversing the root node, the node that we need to traverse is towards left. So that is what the pre-order says. That is, pre-order says that print the node or process the node and then move left and right. Okay. In order says that go to left, D towards left, then print the node, print or process, right? And then move towards right. And this post order says, so I'm just naming, or the traversals has been named using the position of the node. You could see that. Okay. So pre-order is having this node visited first and then visiting left and right. Right? And in order is travel left, visit node and then travel right. So here in post order, travel right, left and then right and then visit the node. Okay, so here as per the logic here in pre-order, I'm going to just visit the node whenever I reach there. Immediately when I reach there, I'm going to visit. So I reach this A when I start the traversal. So I just process it. Processing here is just printing. Whatever process you want to do, you can do. But here, just for explaining you the traversal technique, I'm just printing it. Okay, so I printed A. So what next? I have to move towards left. So I just move towards left here. So I move towards left. Okay, and when I move towards left, where do I land at? I land up at node B. So this is the first time I'm visiting. So pre-order says that print the node or process the node whenever you reach a node for the first time. So this is the first time I'm visiting or I'm reaching at node B, so I visit it. I explore that node. I print that node. So I print and do what? Move left again. Okay. So because that is what is needed. So visit a node and move left. So go left here. So I reach to the node D. So this is the first time I'm visiting D or I'm reaching D. So I'm going to explore that node and print D. Hope this is clear. Okay. So now when I reach D, I'll just try to move further towards left of it. So these are all null fields. So I try to move further here, but it is null. So if it is null, what I do? I have to move towards right, because I've explored this D, visited this D and tried moving left, but left is not there. So I now try to move to right. I just try to move to right. Okay, but right again is missing. It is null. So what I do? I just go back. I visited this and this has also been visited. Now I'm going to visit right. From B I've traversed through left and now I'm going to go to right of B. Okay, B has already been explored. Okay, so now I go to right of B. So right of B is what? E. And this is the first time I'm reaching this node. So I explore that and print. Okay, now from E again you have to, so once you explore a node, go towards left. Try to move towards left of E. Left of E is null. So now you go to right of E. So after you move to left, you have to go right. So when I go to right, again I find it to be null. So you go back. Go back and do what? Visit C. Okay, because A's left has already been visited. So after visiting left of a particular node, you have to visit right. So I have to visit right of A. So right of A is what? C. This is the first time I'm reaching C, so I explore it. Okay. So now when I just reach a particular node for the first time, I have to move to the left of it and explore there. So when I reach left of C, I reach this F, which is for the first time I'm visiting, so I explore it and print it. Now from there, go to left of F. Left of F is null, so move to right of F. Right of F is also null, so move to right of C. Right of C is also null, so go back to root and you are done. So you have come back to the place from where you started, which means that you have visited all the nodes in the tree. So now you could see it is A visited first, then B, then D, then E, and then C and F. So this is the order in which the nodes will be visited if you use the traversal method called as pre-order. So pre-order in short, that is print the node when you reach a node for the first time. Okay, so this is a shortcut. So you have to remember. So this shortcut will help you remember all the three traversal. So for in-order traversal, the rule is this: print when you reach the node for the second time. For post-order, print when you reach the node for the third time. It is as simple as that. But here the actual logic is explore the node, traverse left and then traverse right. That is the actual idea. So here I'll repeat this with this N, L and R. A, B, C, D, E, and F. What this says, start from the root, explore node. So A is explored. So after exploring node, go to left, explore node. You reach a new node, explore it. So go left, explore node, go left, no node available. So go right, no node available. So go back, traversing back. And here this has been already visited and whose left has also been visited already. So if you visited node then left, then you have to go right. So I'll go right. So print E. Now from E I'll go left. I do not find anything, so go to right. And nothing available there, so go back. B has been visited, so go back. A has been visited. A's left has been visited. Now I have to go to right. So right of A is C. And from there, go to left. Because when you visit a node, left, right. So I am in a node, left is F. And from there I again try to move left. Nothing available. So go to right. Nothing available. So go back, traverse back. And it has been visited. So traverse back. This also been visited. So its left has been visited. So you have to visit right. Nothing is there. So go back. So here you have visited the left of it and right of it. This has already been explored. You stop. So this is how it will work. Hope this is clear. Any doubt in pre-order?
No, ma'am.
Okay,
No, ma'am.
I'll explain in order and post. Yes. Okay, I'll explain in order and post order also, and then explain you the algorithm and how the stack will be used implicitly in implementing this traversal technique. Okay, so now let's see the in order traversal. So here in order, let me take red color. Okay, start from the root. What does it say? Move deeper towards left, then explore node, then explore right. So here, if a node where you are now has got a left child, then you have to move towards that. So we move towards left. Okay, I hope you follow this. I am just tracing this tree for in order traversal. Right. So here I start from root and move towards left, and again I reach B. So if B has got left, then I have to move towards left of B, and now I reach D. So here when I reach D, from there again I have to check whether D has got any left child, but D do not have any left child. So if there is no left, what you do, you just come back and read the node from where you have come to the left. So it is D. This is the second time you are visiting D. I am just telling you the shortcut. See, when you just go back, what you do, you just explore the node. Go to left, then explore the node, and then go to right. Okay, from there again recursively you have to go to left. Here I tried moving left deeper into the tree, but I don't find any node here at this point, so I go back and explore the node. So if you just look at this is the second time I am visiting D, so I explore that. Okay, this is the point when we need to explore. Or in short, whenever you reach a node for the second time, you explore it. Okay, so now go left from root and go left from the child of the root, go left from the child of root, and keep doing this till you reach null, and come back, visit the node from where you reached null. Okay, so we have visited this D, and after visiting node, what you are supposed to do, you are supposed to go right. That is what it says. Go left, then visit node, then visit right. So now I am going to visit, say I visited D, and now I am going to visit right of D. Right of D is null. Clear? Right of D is null. What I do? I go back. D has been visited. Now I go back. B is a node which I am reaching now, and B's left has already been explored. So I am going to print B. Okay. So if you just look at the shortcut here, this is the second time I am visiting B, so I am printing. Okay. But as per the logic, you have visited the left of B, so you have to visit the node now, explore the node now. After visiting left, explore the node and then go to right. So here I visited left of B, and now I explored B. Now I have to move to right of B. So when I try to move to right of B, from there I will again try to move to left. So left of E will be checked for. Left of E is null. So I just go back to E and explore E. So after exploring left, explore the node. So now I print E. Okay. Now this is the second time I am coming to E. From B I came to E, and from E I came down and found that there is nothing available. So I am going back to E again. So second time I visited E. So I printed. And now I am coming back and moving to B. B's left, right and node, everything is visited. So go back to A. A has been visited for the second time, or the left of A has been visited. When the left of A has been visited, you have to visit that particular node. So now I am going to explore A. Clear? So after exploring A, what I am supposed to do, I have to go right of A. To the right of A, when I move, I landed C. And C has got left, so I have to go to the left of C, and I land at F. So when I just land at F, what I do, I again from there try to move towards left. So always try to find whether any node where you are has got left child. So F has got no left child. After checking that, you go back to F. So now after visiting left of a node, you have to explore the node. So I now explore F. Now go back to F and come to the right of F. Right of F is null, so go back to F and go to C. So here C is now being visited for the second time, or left of C has been explored already, so you have to explore C. After exploring left, you have to explore the node. So I explore C. Now come to the right of C. Right of C is null, so go back and go back here, and A is the route where this is the position from where you started the traversal, so you stop. So now you could see the difference between the positions of these variables, or the order of these nodes. So it is different here in pre-order and different here in order, and it will be different here in post-order also. So in short, explore the node, or explore the data in the node when it is visited for the second time. This is the shortcut. Okay, this is the logic, this is the shortcut, and here it is when you visit for the first time, explore it. This is explore it for the third time. I hope this in order is clear. Do you want me to repeat? Shall I repeat this, or is it clear? That is clear. Okay. Now let's see how we could traverse the same tree in post order. Maybe I'll redraw it here so that it will not become much more cumbersome. Class முடிஞ்சிடுச்சா? இதுக்கு வந்த பண்ணிப்போ. என்ன சப்ஜெக்ட்? மிஸ் டிஸ்கனெக்ட் ஆகிட்டாங்களா? நீ ஐடியா சரி இப்போ வந்துருப்பாங்க போ. Okay, let's see how we're going to traverse in post-order traversal technique. So again here start from root. So what this post-order says, you have to go left, then right, and after traveling left and right subtree of a node, you have to explore the node. Okay, so now I just start from root. So if this root node has got left, then I have to go left. So I move left. And from there again recursively you do the same thing. From there, assume that this B to be a new root. From there again, you have to go left, then right, and then explore. So here I go left because left is available. And now I try to move towards left from D, but left of D is null. So what I do, I just go back, and now I'm here. I'm here at D, and from there I try to explore the left of D. So left of D is null. So I go back to D and go to right of D. Check whether D has got any right node. So it may have a right child. So I have to check for that too. So I'll just go right of D. So right of D is again null. Come back. So here at this point, you have visited left subtree of D, right subtree of D, and now you have to explore N as per the logic. Okay. So you moved left and found no child there, and then you have checked the right subtree of D, and there again we found null. So we come back and process the node. Go left, right, and then process. So we have gone left, gone right, and now we're going to process. So I process the node, and after processing you have to move back from where you came to D. So I backtrack and move to what? I move to D, B, right? And from B I've already explored left, but a right subtree of B has to be explored at. So I just move to right of B. I'll go back to B and now check the right of B. Right of B has got some node. So assuming that this is the root of the tree where I am now, I have to go check the left. So left of E is null. So go back to E and come check whether E has got right child. Right of E is also null. So go back to E again and explore what? You have explored left, explored right, and now you are going to explore the node. Okay. Now move back to B. So now you are here in B, you have explored left of B, explored right of B, and now it is time to explore the node itself. So I explore B. Now backtrack and move back to A. A's left has been explored, but then right of A is still to be explored, so I just move towards right. Right of A is what? C. So from C again I will go check whether the C has got any left and right. Yes, it has got left. So from there again I will go to the left. So left of F is null. So what next? Go check right. Right of F is also null. So move back. And now left and right of F has been explored, so you have to explore the node F. Now trace back and go to C. C's left is explored, so you go right and check. Right is null, so come back to C and explore C. Now move back to A. A's left is fully explored, A's right is fully explored, and so you have to explore A. So when you go back, you stop because you are at the root. So here if you just look into this traversal, every node is being printed when it is visited for the third time. I will help you understand that. So here when you start from root, you come to the left of root. Left of root is B. So from there again, so you have visited A once and B once. Okay. Now from B you are going to check for the left child of B. So here now you visit D once. So again from D what I do, I have to go check whether D has got any left child. So I just go down from here, from D, and find that it is null. Right? I have already visited D once, and from there I moved left, and finding that left of D is null, I move back to D. Okay, I move back to D. So this is the second visit I make to D. Now immediately what I do is I will just go check whether D has got any right. Okay, that is what we did. So when I just find that D has no right child, I will come back to D. So this is the third visit I make. From D to D, again from left of D to D, and from right of D to D. This is the third time I am visiting. So when I just move back to D now, I explore D. So only during the third visit of the node I do that. So if you just check this B again. So what you do here after exploring D, you go try to trace back to B and check whether B has got any right child. So this is the second time you are visiting B. When you are tracing back from D, that's the second visit you make to B. Now from B again you go to E and do all processing there, and once you are done you come back to B. So this is the third time I am visiting. Now I find that left of B and right of B both are explored, and so I explore B. Similarly here you can check for E also. So E what you make, you come from B to E and you go to left of B, left of E. Left of E is null. So you go back to E. This is the second visit you make to E. Then you go right of E and find that it is empty, and so what you do, you go back to E. So while visiting this E for the third time, we have printed E. So post order is very simple. What we do is we just try to explore a node's data when the node is visited for the third time. Okay, so this is a shortcut you can remember so that you can get the traversal order correctly. Okay, but the idea is visit left, visit right, and then visit the node. So this is to be repeated at every step. That is what I have done. I have started from A and I visited left, and recursively being here at B, I applied the same method, visit left. Being here at D, visit left. Okay, so this logic has to be recursively done at every node so that you get this traversal order correctly. Hope this is clear. If you have any doubts and if you are not able to follow, please let me know here itself, because I want to explain the same with the algorithm or the program. And there that program will not explicitly have stack implemented. You have to understand how stack is being used at the background in the execution of that particular code. இது புரியலன்னா அதுவும் புரியாது. இது நல்லா புரியுதா?
Yes, ma'am.
Okay.
Yes, ma'am.
Right.
Yes, ma'am.
Shall we try another example with numbers? We have this. Shall we try this? In the content, the order is also given here. This tree is a full binary tree, and the tree is bit bigger also. You can try to traverse and check whether you are getting things right. Pre-order தான் இருக்கிறதுலே simplest. Pre-order try பண்ணி பார்க்குறீங்களா? Or do you want me to try? If you want me to try and explain you, I'll do. Otherwise, if you can try on your own and check the answer, you can do. What shall we do? என்ன பண்ணலாம்? No, I'm not getting you, please.
Those two are okay, ma'am. The option you gave, anyone which suits now.
You are not audible. One second. Let me just increase the volume of my system. Yes, please. What shall we do? Should I do it for you or can you try? எத்தனை பேருக்கு கிளாஸ்ல யாராவது ஒருத்தர் ஆன்சர் பண்ணலாம்ல? எஸ்
We basically both, ma'am. Like we want to help and we want to give because we do mistakes. We know that.
Okay, I'll be here. You try and let me know whether you're getting it right. If you're going wrong somewhere, you just ask me. I'll help you. Is that okay?
Yeah, okay, ma'am.
Okay. Okay. You want me also do along with you? Okay, done. Okay, let's start with let's start with pre-order then. Let me take red color so that it will be visible. So this is the root node they mentioned, so we're going to start from here. So pre-order demands that visit the node, then move left and then right. Hope you are also working with me. So here, okay. So this is the first time I'm visiting and I'm going to explore the node. So 25 will be visited first. Okay. Now, what is next? You have to move towards left. So you move towards left of 25. So left of 25 is got a what? 15. And here, this is a node where you actually landed. So you explore the node. It demands that. Explore the node and then go left. So here I land up and I explore it and go left. I land up at 10, explore 10 and go left. Just a moment. మధు అంటాలా? Okay, so here I think you would have completed this thing. Where are you now? Guys, am I audible?
Yes, ma'am.
Yes, ma'am.
Okay, okay. So here 25, 15, 10, then 4. And from 4 I try to move left. Left is not available. Then what I have to do, I have to go right. Go right. That is, go back to 4 and check whether 4 has got any right. So I have gone back to 4 and now I am checking whether this 4 has got any right. No right here. Again I go back to 4 and this part of the tree has been completely explored. So I go back to 10 and here I have explored this node and explored the left of it, and now I have to explore the right of that node. So go to right. So when I move to right, I land up at a new node, so I explore the node. Whenever I land up at a new node, I explore. So that is what it says. Node first, explore the node first, and then left and then right. So now I go left. Going left, I find no element there and go back, and now check right, no element there, so go back, and here again this part is explored, this is explored, go back and go to right. Right is 22 and come here to the left. Left is 18. Go back to 22 because you are not going to find this left and right here. After checking all these things, I'll go back to 22, and from 22 I go to 24 and check whether this 24 has got left and right. No left right, so go back. 15 explode, 25 explode, so now right, so 50. Now check the sequence. It is 25, 15, 10, 4, 12, 22, 18, 24 and 50. So we are doing it right. And now from 50 to left, so 35. From 35 go left, print 31. From 31 go left, nothing found, go back. Check right, nothing found, go back. So here processed, go back. This is processed, go right. 44 and go back. It is 35. This part is fully processed, so you go back. This is processed, so you go right. Left of it is processed. Your processed node, processed left and coming to right. So now 70. From there you check left. Left is 66. And now go left, nothing found, go right, go back, come right. So you have 90. Go back, go back, go back. You stop. So this is sequence we get 35, 31, 40, 70, 66 and 90, and we are done. I hope you all are getting this.
Yes, ma'am. We are getting,
Right.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, that's fine. Okay,
Same
let's
thing.
right, very good. Now let's try in order. Shall we?
Yes, ma'am.
Okay, let's try in order. Let me just erase it off. So start from root.
Uh,
So what does in order say? Go left, then process node, then go right. So here, when I'm at 25, I just check whether this 25 has got any left child. If it has got left child, then I have to go to left. I should not process this now, as I did in the case of pre-order. So here, I am not processing it. I am just checking for left. So this node should be explored or visited only after exploring the left child of 25. So it is not a single child what this 25 has got in its left, it is a subtree, right? So you have to go there and again do the same step. So you land at 15. So landing at 15, you have to check whether you have to process this 15 or you have to go left. This 15 has got a left child, so I'm going to go left of 15. Go left of 10 and go left of 4. Left of 4 is not found, so you go back to 4. And now after processing the left, you have to process what? The node. So I have processed the left of this node, and now I am coming back to this node, so I have to explore this node. So I explore it, I print it. Hope I am clear and it is also clear for you. Okay, so I have gone left and came back to the node and processed it. I am going to go right now. So right of this 4 is null, so go back. This part of the tree has been completely processed, so you are going to go back. So when you are here at 10, you know that the left of 10 has been processed, so you are going to process this 10 now. So I explore or print 10 and now move right. Moving right, again I have to check whether this has got any left or a left child. If there is no left child, go back to 12 and print it. Now go right. No right child, so go back. Now you go back and here you are for the second time. This is 15 whose left subtree has been fully explored. Now you have to visit this 15. Now go right. Before moving to the right of that node, you have to process that node. That is what it says. Before going to right, you process the node. So I processed it and I am coming to the right child of 15. Right child of 15 is 22 and from there again you check whether this has got any left child. Yes, it has got a left child, so you are going to go there. So being here at 18, go check for left of 18. Left of 18 is not found here, so I come back to 18 and process this before I go to the right of 18. So here right of 18 is found to be null, so go back, come back to 22 and 22's left has been processed. So before you go to the right of 22, you have to process 22. So now go to the right of 22 and from there check left. Left is empty, so I go back to 24 and before going to right of 24, process it. So 24. Now go back to 22, it has been fully processed. Now go back to 15, fully processed. Go back to 25 and before going to the right of 25, all towards the left of 25 has been processed. So now we have to process 25. Okay, now go to the right of 25. Right of 25 has got 50, which has got left child in turn, so you have to go to left. You should not immediately process. You have to stop at every node and check whether it has got left child or not. Only if there is no left child, you have to process the node and then go to right. Okay, but here this 50 has got left, so what I do is I go towards left and check land at 35 and again from there I check whether it has got any left child. It has got a left child here, so I go to left of 35 and from where it is 31 and from 31 I go to left. Left of 31 is not found, so I just go back to 31 and process 31. Go to the right of 31 after processing it. So right is also empty, so go back to 35. Now entire left of 35 has been processed, so you have to process 35 before you go to right of 35. So right of 35 is 44, so I print 44 because 44 is leaf node, because you are not going to find left and right, so I just go back after printing 44. 35, if you just work with many number of trees, you'll also get this flow. You can do it very quickly, right? So go back to 35 and 35 has been completely processed. You go back to 50 and now you're going to process the right child of 50. So before processing it, you have to process this 50. So you go down towards right of 50. That is 70. Go check whether the 70 has got any left child. Yes, it has got left child. So you come to left of 66. Process the 66 after determining the left child, null and left, and now go to right and then go back, and before you go to the right of 70, process it. Come to 90. 90 is a leaf, so we are going to process it and go back. Processed, fully processed, fully processed, you stop. Now let's check whether the order is right or wrong. It is 4, 10, 12, 15, 18, 22, 24, 25, 31, 35, 44, 50, 66. Yes, we are done. Are you all getting this?
Yes, ma'am.
That's great.
Thank you,
It's
ma'am.
12:38 and I need at least half an hour to explain the algorithm because it will be a bit lengthier. So this is how the algorithm will look like. This is the algorithm for pre-order. It is very simple, easy to by heart. This is not an algorithm. This is the program what I have taken from the net, written in C, where the tree is implemented as a linked list. And because in the previous class I've told me that it will be better if I just explain the code itself. So this is the code for in order. So algorithm will also look similar, right? So here the code is very easy and simple. You could see in order of roots left, then print data, then in order of root right. For pre-order, the order is going to vary. You're going to have a different function name. So this is a function. I haven't taken the complete algorithm. I have just taken only the code segment from the traversal code, complete traversal code, because I'm not going to explain the complete code. It is only the explanation of the concept here. So I have taken only the part of the code, right? So the other part of the code wherein there is a function for pre-order and post-order, it will look like this. You'll have, in the place of in order, you'll have pre-order, and the order here will change. First you'll have this cout, print the data, then pre-order of route left and pre-order of route right. You can check it here. So here this is the pre-order algorithm or the code. So this function name is pre-order. You could see in the pre-order you have to first process the data. So you should have this printing statement first and then call to the function pre-order. This is a recursive call to the same function. See, you could see here the function name here and here are the same. The function calls itself inside the function, right? The same function is being called. This is called as recursive function. This is what you would have tried in implementing factorial algorithm also.